simplifying radical expressions, or just radicals with numbers in them, the first thing I want to do is see if it is a perfect square. So knowing your perfect squares can help a ton here. 1 squared is 1, 2 squared is 4, all the way down to 10 squared is 100, right? So recognizing the numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169. It's particularly helpful. But this is not a perfect square, and square root of 32 is going to be some number less than 6. So one strategy to do this is to take the number inside and factor it. So I know that I can make 32 out of 2 times 16, I believe, is what I get when I divide 32 by 2. So if I keep that under the square root, I can now see that 16 is one of my numbers. It's right here. 4 squared is 16. So if I realize that the square root symbol is just an exponent, then I can say, well, you know what? An exponent on 2 times an exponent on 16 are going to allow me to do the same thing. These are equivalent statements when it is multiplication. All right? And the square root of 16 turns out to just be 4 when simplified. The square root of 2 doesn't simplify. It's an irrational number. 2 is not on our list of perfect squares. So the final step would be to write it in standard form, which just is 4 root 2. You don't even need the times symbol when you put the whole number, or the coefficient, in front of the radical sign. So this fully simplified is 4 root 2. Now I want to show you a second strategy with 32. I could rewrite the square root of 32 in terms of all of its prime factors. 2 times 2 times 2 times 2 times 2, I believe. So 2 times 2 is 4, then 8, then 16. Is that too many? Yeah, no, 16, then 32. Here we go, right. So when I write out all the factors, I write 32 fully factored, meaning written as a product of all of its prime pieces. I can go ahead and identify pairs of those, and for each pair, a number will come out front, 2. So the square root of 2 times 2 is 2. And the square root of 2 times 2 is 2. And the lonely factor gets to stay inside. So that's the square root of 2. Now when all of this is multiplied, so when I simplify this, I get 4 square root of 2. The same answer I got up here. You should always get the same answer no matter what method you use or which way you think about it. But that is another strategy for coming up with the simplified radical. I always want to check my work. So I can type in 32 square rooted, and I get the number 5.6568. I can also type in 4 times 2 square rooted, right? See, 4 times the root of 2, and I should get the same number, 5.6568. So that's how we check our work with a calculator. So I briefly mentioned that the radical sign is an exponent. I want you to know that you can rewrite the square root of 108 as 108 raised to the 1/2 power. That whole fraction is the power that represents the square root. And now if we use our factoring method, like we did over here in purple, I can rewrite 108 as 2 times, 54. 54 is not helpful, so let's do another 2 times 27. 27 is not particularly helpful. It's a perfect cube, but not a perfect square. So 3 times 3 times 3 is 27. So here's my fully factored version of 108. And again, I talked through but did not write down my factor tree. Hopefully you've seen a factor tree before. All of that's raised to the 1/2 power. And if you'll remember your exponent rules, that means that I can raise my 2 times 2 is 4. That's a perfect square to the 1/2 power. I can raise my 3 times 3 is 9. That can be raised to the 1/2 power. And then I'm left with 3 still raised to the 1/2 power. This is my lonely factor that can't go outside. But when I raise 4 to the 1/2 power, that's square root of 4, which is 2. The square root of 9 is 3. And then the square root of 3 is still the square root of 3. I can simplify this then by multiplying my 2 and my 3 to get 6. Get rid of the times symbol because I don't really need it. And this is the simplified version. Again, if you don't believe me, for any reason, I can always type in 108 raised to the 0.5 power, and I get 10.39230 blah, 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 which is the same thing as 108 square rooted, 10.323 blah, 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 same number. Or 6 times 3 rooted, and I get 10.323 blah, 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 blah. The same number for all 3 of these different ways of seeing square root of 108. Now I'll do the other solution strategy, which was to pull all of the factors out, right? So if I had the square root of 2 times 2 times 3 times 3 times 3, I can grab the pairs and leave my lonely ones inside, and this becomes 2 times 3 times root 3, and again it's 6 root 3. Notice there's 2 factors of 2 inside. Only one gets to come outside because of the 1/2 power, right? 1/2 says, how many times do I multiply my base, 2 here, by itself to get 1/2 of them? Yeah, I don't know. But it's half of them. There's 2 here, so I get only 1 out when I raise it to the 1/2 power. And I don't think I'm going to do this one for you. It was kind of part of this one over here, if you'll recognize. 8 is also just made up of 2's. But make sure you're using what you already learned to do future problems. I wanted to talk through these add and subtract expressions with radicals. These are fully simplified in problem 10. If you have 5 root 3's minus, and you take away 4 root 3's, you should recognize what you have left. Think about it as like terms, right? But 12 root 3's minus 3 root 12's isn't quite as straightforward. It looks like I can't really combine these because I have no like terms. It's not 3x or 12x minus 3x. It's 12x minus 3y. So we need to figure out if we can rewrite root 12 as something different. I'm going to bring down my whole thing, 12 root 3 minus 3 times. Now instead of root 12, I'm going to factor it. I've got 3 times 4. 4 is a perfect square. So actually, if I rewrite it as square root of 3 times the square root of 4, then I can see that this whole thing turns into a 2, because 4 is a perfect square. So I have 12 root 3 minus, now I can combine my 2 and my 3 to be 6 root 3. Now I have like terms. So if I have 12 root 3's and I take away 6 root 3's, or if you think of it as factoring out the common factor of root 3, same, then 12 minus 6 is 6 root 3's left over. So that is how you would approach these types of problems. Try and simplify your radicals until you can get a common factor that is the remaining radical. And then add or subtract their coefficients, just like we do for combining like terms in algebra with x's and y's. These problems give you a reason for why we're learning a lot of this radical math stuff. And it is because when we find lengths of segments, like we have been doing since, I don't know, the 2nd or 3rd week of school, we need to use the Pythagorean theorem or the distance formula, which is one big radical, one big square root. And so when we find the length of EF, I'll use a brighter color, we need to find the height and the width, and then set up either Pythagorean's theorem or the distance formula. If I go straight to the distance formula, everything's under a square root. And I've got 3 squared plus, what did I get here? 1, 2, 3, 4, 5, 6, 7, 8, 9 squared. And hopefully from the previous Desmos activity, you don't want to turn this into 3 plus 9. That is not okay. Think of this as 3 squared plus 9 squared raised to the 1/2 power. I have to simplify what's inside before I can apply the power. So I simplify and I get 9 plus 81, and that turns out to be square root of 90, but that's not fully simplified. I'm going to go ahead and simplify it because I have a feeling when I add it down here I'm going to need that. So this is the square root of 9, which is a factor of 90, times the square root of 10, which 10 is made up of a 5 and a 2, and square root of 5 and square root of 2 are both irrational, so I can combine them here and leave them as root 10. But 9 can be simplified. This is 3 root 10. So now I want to find CD, and then I can add them and see if they maybe have a common factor of root 10, perhaps, when simplified. But these are the reasons that we want you to get better at this. Now there's one little glitch in this homework, and it is that we have not yet taught you how to fill in the gaps on this, this problem here, 23. So I want to tell you that if this is 4, then y is 4 times root 3. And then hopefully you can find the hypotenuse of this. If this is 4 and this is 4 root 3, find the hypotenuse. And then ultimately you're not solving for x or y, you're finding the perimeter of each figure. That's what we want you to find. So in this case, the side length is 3 root 2, but there are 4 sides. You can either add all 4 up, or you can multiply because they're the same thing. But make sure you simplify the expression that you get there. And here again, solve for the hypotenuse, and then in simplifying those radicals, you should come across a good answer for that. Then you add them up. Make sure you do not add unlike terms. If, for example, no other sides have a factor of square root of 3, then you're going to be left with some other number plus 4 square root of 3. And maybe these numbers combine, or maybe another number combines here, but it's okay. This is a valid format for a fully simplified expression with radicals when there is no common radical between them. Let me know if you have any questions. See you in class.